All right, we're going to do a free response question, just one question right now. You need your calculator, or you can use decimals probably, but take out your calculator as we go through it. Um, and this is just one question with four parts that we're going to do right now. This is from 2016 practice exam. In 2016, the College Board kind of changed some things with calculus, so this is kind of the first year where we look at to know that something similar we'll be looking at. All right, uh, let's read number one together, and we'll annotate it and try to understand what we're going to be doing. The depth of a water tank in inches is modeled by a differentiable and increasing function. So differentiable and increasing. So it's continuous and it's going up, 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 up from 0 to 10, where t is measured in minutes and h is measured in inches. The values of h at t for selected values of t are given in the table above. So first of all, the first thing I look at is that this h, or my y value, is not a rate. So it's just inches, not inches per minute. So we take out a table of values of something like that. So the first question asks for use the data to approximate the derivative at around 6. So when I see that derivative, I have a sense that it's going to mean off a table of values, could you find the slope? There's no equation to use there, so there's not any rules to differentiate. Instead, you understand with the table of values, the derivative means slope. I also don't see 6. So to find the slope, we're going to take 2 points that surround 6 to find it. So what would this look like? So the derivative at 6 would be y2 minus y1, just a slope formula. So it's 18.5 minus 15.5, and then 7 take away 5. So take the values that you see there. If you use your calculator, you get the answer 1.5 if you put it in. And we need units. And so what would the derivative be for units? Now we need a rate. And that would be inches per minute. So, and then show the computations that lead to the answer, which we did. All right, B. You could be asked also for 1A is what does that mean, the derivative? And the derivative would mean at approximately 6 minutes, the rate the water is entering into the tank is about 1.5 inches per minute at 6 minutes. That's what it means. All right, B. Approximate the value of 0 to 10 ht by using a right Riemann sum with the 4 subintervals indicated by the data in the table. In this approximation, is this a greater or less than the actual value, and give a reason for your answer. Okay, so we're going to integrate this. So from 0 to 10, we have 1 interval, 2 interval, 3, 4 intervals. So can you see the 4 rectangles that we're going to create? They are not equal width, so each one's going to be separate. So the first rectangle, the width goes from 0 to 2. And because it's a right Riemann sum, we're always going to use the right y value for the height. So from 0 to 2. So first of all, we're going to write down what we're doing. So we're going to approximate the integration. So the first width is 2. And then we're using the right. So at 3, what's the y value? So it's 10. Plus the next width, 2 to 5. Well, that's width is 3, and then the right value for the height would be 15.5. 5 to 7, the width is 2. The right value, Riemann sum, would be 18.5. And then 7 to 10, that's 3. And then the right value would be 20. So just by doing that, you're doing a proper right Riemann sum. If you used your calculator and just typed it all in, the answer would be 163.5. And then there's a second part to the question. So the first part is, could you approximate the value? We did that. The second thing is the approximation greater or less than the actual one? So is it an overestimate or an underestimate? So if something is increasing and you do a right Riemann sum, and it's good for you to actually get a picture of it. Oops. Let's do it right. All right, here, a right Riemann sum. So you're using the right value all the time. Is it going to be an overestimate or an underestimate? So as you're moving along here, are these rectangles more or less than the area under the curve? And it overlaps the curve above it. So what you're going to say is, when it asks for, is it greater than or less than? And the answer is, the approximation is greater because h at t is increasing with a right Riemann sum. And that's what they want to see. So why is it greater? Because the function is increasing with a right Riemann sum. So they like to see increasing and right. Now, if it was a left Riemann sum, it would be an underestimate. Again, it's nice to have a picture to make sure you can picture what that is. Is it going to be above the curve or under it if it's increasing or decreasing? All right, part C. The depth in water tank B in inches is modeled by this function from 0 to 10, where T is measured in minutes. Find the average depth value. That's another word for average value over the interval. So this is tank B. Before we were looking at tank A. So it's totally different tank, different values completely. And then it says over the interval 0, is this value greater than or less than the average depth of the water in tank A over the same interval, and give a reason for your answer. So first of all, what's the average depth of the water in the tank, average value of the function? What is that type of question is that? So it's an integration question. We don't need to rewrite all of that. We're just going to take that whole function g at t, and then we're going to divide by the difference of the bounds, and now use our calculator. So now we're going to type it in and round to 3 decimal places. So let's do that together. Let me clear this out. All right, so we're first I'm going to do divide sign first, and then I'm going to integrate. And I'm integrating from 0 to 10. Oops. And I'm going to type that in. So 3.2 plus 17.5, the square root of sine, and it's 0.16, it could be t, and then just make sure it's dt. And then in the bottom would just be 10 take away 0 or 10. So control enter. And what's the average height there to 3 decimal places? And it's 16.624. So the average height of the tank for the first 10 minutes is just over 16.5 inches. That's for tank A, or tank B, I mean. You can label that. For tank A, what would we do to find the average height of the tank? So again, the same thing. We're going to integrate, but if you look back, it's not g, it's h. So this would be h at t dt divided by 10. So the same setup. We're going to use the number we just got in part B. So what was the estimate we used for that? So we had 163.5. That was from part B, right? Yep. And then we're going to divide that by 10. I don't need to just move the decimal back, and I get 16.35. Now the question is the value greater than or less than the average depth of the water in tank A? So the answer is tank B has a greater average depth, right? So 16.625 is greater than 16.35, and 16.35 is it which is an overestimate. Therefore, tank B has a greater average depth of water. Over the first 10 minutes. Oh, they go off the screen. All right, last one for today, part D. According to the model given in part C, is the depth of water in tank B increasing or decreasing at t equals 6? And give a reason for your answer. So to know if it's increasing or decreasing, it's the derivative. So I want to find the derivative at 6. That will tell me increasing or decreasing. In other words, if the answer is positive or negative, that will tell me. So I'm going to type that in, and I want to see what the answer is. So what is the derivative at 6? So let's go back to our calculator. I'm going to go derivative. I'm going to use the letter T, and I'm just going to type that in, 3.2 plus 17.5, the square root of sine 0.16t. Now, at the end of it, to evaluate at 6, I go control equals, and then the vertical line, and then type in t equals 6. Control enter. And what do you notice about the answer? It's positive 0.887. So, what do we know? So at t equals 6 minutes, tank B is what? Increasing or decreasing? So it is increasing the depth of water. Why? Because the derivative at 6 is positive. And you could write that out in words if you want to. But we looked at the derivative is greater than 0. Therefore, at 6 minutes, the tank is increasing at that time. All right. You just did a free response question with me. I appreciate you. Mr. G Math, over and out. We'll do another one next time.